Sound moves through helium almost 3 times faster than it moves through ordinary air. And that single fact is the entire secret behind the squeaky helium voice. Inhale from a party balloon, say a sentence, and within half a second you sound like a cartoon chipmunk. The obvious guess is that your vocal cords start vibrating faster. The guess is wrong. Your vocal cords barely change speed at all. What actually changes is something most people have never even heard of: the resonance of the empty space above them. Let's open up your throat and see what's really going on. Every voice begins in the same place. 2 folds of tissue in your throat called vocal cords. Air from your lungs pushes past them, and they flap open and shut tens or hundreds of times a second, chopping the airflow into a buzzing pulse. That buzz is the raw material of your voice, and its speed sets your basic pitch. Breathe in helium, and that flapping rate hardly moves. The buzz stays almost the same note it always was. So if the buzz doesn't speed up, why does the sound come out high and thin? Here's the myth. People assume helium makes your vocal cords vibrate faster, like speeding up a record. That's wrong. The cords barely budge. The truth is stranger. The buzz stays put, but the room it echoes through changes completely. And that room is your own throat, mouth, and nasal passages. Think of your vocal tract, the throat, mouth, and nasal cavity, as the tube of a wind instrument. The buzz from your cords is just the raw energy, like the reed of a saxophone. It's the shape and length of that tube that decides which frequencies get amplified and which get canceled out. Those amplified frequencies are called formants, and they're what actually give a voice its color, its vowels, its identity. Here's the physics. Sound is a wave of moving air, and how fast that wave travels depends on the gas it's moving through. Helium atoms are far lighter than the nitrogen and oxygen that make up normal air, so a sound wave races through helium almost 3 times faster. Your throat and mouth haven't changed shape at all. They're still the same length tube, but now a much faster wave is bouncing around inside them. A faster wave means the tube's natural resonant frequencies, the formants, shift way up. The buzz from your cords is still humming along at roughly the same fundamental note. But the formants riding on top of it, the ones that used to sit low and rounded, are now shifted dramatically higher. Your brain has never heard that combination from an adult-sized throat before. Low, fundamental, sky-high formants. So it interprets the whole voice as small, squeaky, and cartoonish. It's an illusion built entirely from a shifted echo, not an actual change in pitch. Swap helium for a heavy gas like sulfur hexafluoride, and sound slows down instead, dragging the formants low and making your voice sound like a demonic bass for the same reason in reverse. Deep-sea divers deal with a real version of this. Crews breathing helium-oxygen mixes for deep dives come out sounding like Donald Duck over the radio, and topside engineers have to electronically unscramble their words before anyone can understand a status report. One serious warning worth landing here. Never inhale helium straight from a pressurized tank. It can displace the oxygen in your lungs in seconds, which is genuinely dangerous. Party balloons only, and never more than 1 breath at a time. So next time you huff a balloon at a party, remember what's actually happening. Your vocal cords are basically unchanged, doing the same job they always do. It's the empty air in your own throat that's been tricked into ringing at the wrong frequencies, and your brain reads that shifted echo as a squeak. Same voice, faster room. If stuff like this makes you want to know how one more everyday thing actually works, that's exactly what we do here. Subscribe at Cutaway 360. We keep cutting things open.